Hey guys, this lesson is going to be about inequalities. The components we're going to look at concerning those are going to be vocabulary and graphing. It's important that we know the symbols that are associated with inequalities. We have the less than symbol, and some words that mean less than could also be fewer than, smaller than, and there may be a few others. And these words are especially important when you have to write inequalities from word problems. And then we have the greater than symbol. The proper name would be greater than, but words that indicate that could also be more than or larger than. So these would be numbers that are not equal to the number in question. They would either be less than that number or greater than that number. And then we have the less than or equal to symbol. Now you'll notice that little line underneath the less than symbol does mean equal to, so it can include the number in question in addition to anything less than that. And then we have no more than. At most is a weird one. At most looks like you're going to have something greater than, but it's not. It gives you kind of a limit, so at most means you can go up to that number, but then no more. And the maximum. Maximum is another word that reminds you of larger than, but it's not. If you have a maximum speed limit, or if you have a maximum amount you can spend, there's a limit to the top, and then it's anything below that. But notice it can also include that limit. And let's look at some greater than or equal to terminology. Greater than or equal to, no less than. If you need no less than 3 hours for homework, 4 hours would be good, 5 hours would be good, but no less than gives you a lower limit. At least, if you need at least 10 people to show up to help, you would be great with 20 people. At least means there's a lower minimum, so it's greater than or equal to. And then minimum. Sometimes in larger cities you have a speed minimum. They don't want you to go any slower than a certain amount to keep the flow of traffic moving. So minimum gives you, again, a lower limit, but then anything above that is okay. Now I think I thought of another one. Let's use limit, like if there's a weight limit or a height limit, you're looking at an upper limit. So that would fall under less than or equal to. Okay, let's look at graphing. If you had to graph p less than 8, I want you to think of the variable as all the answers. So when you see that, say, all my answers are less than 8. Now be careful. I've also written the flip of it, but you'll notice the greater than part is still toward the 8, and the p still has the less than pointed toward it. So when you see the letter, that's where you start reading the inequality. Either side that it's on, you need to start with all my answers are less than 8. Now if I ask you to graph this, I don't need huge number lines. Go to the number in question and then show me one number on either side. Be really careful when you have negative numbers. So this is all my answers are less than 8. Notice it doesn't say equal to 8. Since it says less than 8, draw an open circle on 8. That just is an identifying point of where to start. But then all my answers are less than 8, you're going to shade the number line to the left, because everything to the left of 8, even the rational numbers like 7.999, anything less than 8 is a true statement. So we shade everything to the left. So 7 is a solution, 6 is a solution, negative 10 is a solution, negative 1,000 is a solution. Hopefully you get the picture there. Let's look at some greater than graphs. So if I say m is greater than negative 2, that means all my answers are greater than negative 2. The other way that can look is negative 2 is less than m. Regardless of where your inequality is, find the variable and start there. And instead of saying m is greater than negative 2, say all my answers are greater than negative 2. So on your number line, graph negative 2. Now it says greater than, so it's an open circle. Put a number on either side of your negative 2, the number in question. Now be careful, since it's negative, you're counting to the left. So it's going to be negative 3 to the left of negative 2 and negative 1 to the right. Now let's put an open circle. That says all my answers are greater than negative 2. So do we shade to the right or to the left? Hopefully you said to the right. So would negative 1 be a solution? Sure. Negative 3? No. What about 10? Yes. 4.5? Yes. 1/2? Yes. Anything to the right of -2. Even -1/2 would be to the right of -2, so it would be a solution. Okay, let's look at some that have the equal to bar. V is less than or equal to -4. So if you draw your number line and put -4 on the number line, the number to the left would be -5, the number to the right would be -3. So this is less than or equal to, so I can actually include -4 as a solution. So this time, instead of an open circle, I close it in. -4 is less than or equal to -4. But what other numbers? Would it be to the left or to the right of -4 if it has to be less than -4? So it's going to be to the left. So shade all the way to the left. So is -4 a solution? Yes. Is -3? No. Is -5? Yes. -10? Yes. -4.5? Yes. Anything to the left of -4, but also including -4 because of that bar underneath it. Another way this looks, if you just flip your inequality around, it's the exact same inequality. They just put the -4 on the left and the V on the right. But notice, in both inequalities, the open mouth is toward the -4 and the closed mouth is toward the V. Regardless of which one you have, start by saying the answers are less than -4 because you read it from the variable standpoint. Let's try one more. X is greater than or equal to 4.5. Or if you flip it around, still read it from the standpoint of your inequality. X is greater than 4.5. So all my answers are greater than 4.5. To graph this, find 4.5 and then tell me a number on either side. A number to the left would be 4. A number to the right would be 5. Just tell me the whole numbers on either side of that fraction. So now if I graph this, it's greater than or equal to, so I get to graph the 4.5 with a colored circle because it can include 4.5. But then greater than would send my shading to the right. Anything to the right of 4.5, including 4.5, would be a solution. So 5 would be a solution, 10 would be a solution, 9 would be a solution. Good job. I hope you enjoyed this, and if you need to refer back to this when we're writing inequalities or if you have to graph them, feel free, slow it down, watch it as many times as you need to.